Substitution's not always your best method for solving systems of equations. There's another method called elimination that helps us out when sometimes we can't easily isolate a variable. And actually, if you look in this middle example that I'm going to do, this one would be kind of a pain to do using substitution. You're going to have to end up with fractions, like you might, if you want to isolate that t or the s, let's say we want to isolate the s, you've got to subtract the 5t over, divide by 6, you're going to have like a 1/6 and a 5/6t, and it just get a little convoluted. There's a much easier way to solve this called elimination, and we use this when our variables, our equal signs, and our numbers kind of all line up. So if we look at that, this would be a good setup for elimination. And I'm not going to do this one first. I'm actually going to start over here. But what we do to start these off is we add the equations together. And I do this when I notice that there are things that I'm going to refer to as evil twins. Basically, you've got a negative 4x and a positive 4x. They're evil twins. And if I add these two equations together, meaning add the x's, the y's, and the numbers, it's possible here we can get a variable to get eliminated. And in this case, since these are evil twins, negative 4x and positive 4x will eliminate. They'll cancel out. If I add them, they cancel. Now I'm just going to keep adding down the column here. So 2y and negative 3y will give me a negative y if I add them, or negative 1y. That equals, if I add these two together, I get negative 2. And actually, we've already pretty much just solved for the y variable. That if we divide negative 1, we get y equals 2. So I'm just going to pop that in right here. So the y-coordinate of the point that these two lines meet at is 2. Now, we've got the first part done. Let's go ahead and take, just like substitution, we're going to go back to one of these original equations and plug that 2 back in to find the x. So I'm going to use the bottom one. Let's go with 4x minus 3, and I'm going to replace that y here. Since I solved for y equals 2, I'm just placing it right in there for that equation. Equals negative 10, and now from here we'll get 4x minus 6 equals negative 10. All I got to do from here is add the 6 over, so I get 4x equals negative 4, and if I divide by 4 on both sides, we should get x is equal to negative 1. So the ordered pair that this line, that these two lines cross at, is negative 1, 2. Okay, so that takes care of the first one. Let's try this next one. All right. Again, I'm going to add these together because I have evil twins here. I've got a positive 5t and a negative 5t. So if I add down this first column here, I'll get 6s and 6s. They are not evil twins, so they won't cancel. That'll give me 12s. These are evil twins. One's positive, one's negative. They'll cancel, which eliminates the t variable, which is nice because now I'm just working with s's. And then 1 plus 11 is going to be 12. So look at that. This is going to be really easy. That gives me that the s variable is just 1. And whenever we get variables that aren't x or y, just replace that variable with, whichever one comes first in alphabetical order. Like here, the s comes first before the t. Put that in the order of your ordered pair. Okay, so now that we found this, remember, just like with substitution, we're going to plug this s back in. I think I'm going to use this top one this time. And then I'm going to plug this back in to see what we get. So 6 times 1 plus 5t is equal to 1. So 6 times 1 is 6. And then if I subtract this 6 over to the other side, I'm going to get 5t equals negative 5. And dividing by 5 on both sides should get me that t is negative 1. So the ordered pair that these two lines meet at is the ordered pair 1, negative 1. Again, just like with substitution, we can plug these back into the original equations to check our answer to make sure they work. Remember, you have to check both equations, not just one. Now here, we're actually going to have a problem, and you may notice that if I add these up, I'll get 26a, because they're both positive, plus 16b is equal to negative 4. And this is a problem because we didn't eliminate a variable like we did in these. There actually was no evil twin in this example. So when we have a problem like this, what we're going to do is we're allowed to multiply one of these equations by anything we want so that we can get evil twins. And if you notice, the 13a's are pretty darn close to being evil twins. They're identical twins. If I could multiply by something to make that 13a negative, I'll be in good shape. So here's what I'm going to do. All I'm going to do is I'm going to multiply this bottom equation by -1. Okay, I'm going to distribute a -1 into everything. What's going to happen then is that 13a will be -13a when I'm done, and then when I add them, they should be evil twins, and the a's will cancel. So I'm going to keep this top equation exactly the same. I'm not even going to mess with this. This will be plus 5b is equal to -11. I'm not doing anything to that. Now this one we're going to multiply by -1. And again, I can't just multiply one thing by -1. I've got to multiply everything in here by -1. All that's going to do is flip all these signs around. -3a, -11b, and equals -7. So now notice when I add these up, now these 13a's are going to eliminate like I want them to. So 13a cancels with -13a. Now we'll get -6b is equal to -18, and again you can see this is going to solve very nicely. If I divide by -6 on both sides, we get b is equal to 3. Okay, so if I plug this all in, we'll end up with the ordered pair. Again, b comes second in alphabetical order, so I'm going to put the 3 here. And then we're just going to go ahead and plug this in one more time. Okay, so if we plug this in, we're going to end up with, and I think I'll use the, let's use the top equation this time, so let's use this one. We'll get 13a plus, I'm just going to go right to 15 here. 5 times 3 will give me 15 equals -11, and then just like before, we'll solve for the a. So I'm going to subtract. We'll get 13a is equal to -26. Dividing my 13 over, I should get a is equal to -2. And again, if I check my answer, that should give me an ordered pair that works in both equations. It's just another way to solve systems. So we talked about graphing. Graphing, we said, wasn't always the best because what if they don't meet at an even point? Luckily, these do. It made our math a little easy. We talked about substitution, which is a great method when you have a variable that's isolated. You know, if one of your equations looks like this, x, is equal to y plus 3, then you're in good shape for substitution. But if it's not, and if you look at this one, if you had to isolate a variable, you're talking about some ugly decimals. So in this case, if all the variables, the equal signs, and the numbers all kind of line up here, elimination is probably your best bet.